12.4, day number 3. Example 1a. The last of our 3 shortcuts that we're learning in 12.4 is the quotient rule. Quotient is the answer to a division problem. So when we're taking a look at using the quotient rule, we're going to have a fraction to start with. How the book says it is that our original function is equal to 2 functions that we're dividing. F of x is on the top and g of x, that's on the bottom. When you do the derivative, this is the formula for the quotient rule. Again, it looks a little complicated, but we'll run through it. You'll be able to see where all the parts go. It still is way easier than going through and using that method we had in section 12.3, where we were finding the slope of the tangent line at any point. Again, that's what the derivative is. They're synonymous. So when we do the derivative, we could be using that big, long rule that we did in 12.3. Otherwise, this is a reasonable shortcut. Saves us a lot of time, actually. I'm going to approach this exactly the same way I did 12.4, day number 2. I'm going to go through, and if you take a look at the right side of this formula for the derivative, there are just 4 things that we need to know. We need to know f of x, which is the top of the original fraction, and we need to know its derivative, f prime of x. We also need to know g of x, which is the bottom part of the fraction. We're going to use that here, and then also on the bottom of the fraction here. So g of x gets used twice, and then its derivative. So we need to know f and f prime. We need to know g and g prime. Once we know those 4 things, then we can use the rule. The original function, h of x, is equal to f of x over g of x. So the top part of this, that is what f of x is equal to. And just like I did with the product rule in day 2, I'm going to write down what f of x is equal to. And then I'm going to write underneath it its derivative. I need the derivative, so I'm going to go through and do f prime of x here. Using our power rule shortcut from day number 1, I know if I do the derivative of a term that just has an x to the first power in it, the answer is just the number in front, and the derivative of a constant is 0. So when you do the derivative here of 7x minus 10, using our power rule, we get 7 plus 0, or just 7. That's 2 of the 4 things that we need to know. The other 2 things are g, which is in the bottom of the original, and its derivative. So let me copy down g of x. That is equal to 12x plus 5. And then let me do its derivative using the day 1 shortcut, using our power rule. The derivative of something with just an x to the first power in it is the coefficient, just the number in front, and the derivative of a constant is 0. So the derivative of function g, the derivative of 12x plus 5, is 12 plus 0, or just 12. When you go and take a look at h prime of x and its formula, up in the top, it starts with f prime and g. F prime and g are these 2 inside values. And then after a subtraction symbol, there is f and g prime, and those are the outside ones. So just like we did with our power rule, when we go through and use the quotient rule, we're going to multiply the insides together, multiply the outsides together, but with the quotient rule, instead of addition here, there's subtraction, and we have g squared on the bottom. Our function g of x, we're going to put that on the bottom part of the fraction and square that. Okay, so let me take our formula and write that down again here, but I'm going to spread things out a little bit. So here is the formula, h prime of x, this right here, that's equal to f prime of x times g of x minus f of x times g prime of x, and then all of that is over g of x squared. All right. So now I just need to plug in our 4 values and come up with our final answer. So to start with, h prime of x, that is equal to, well, it's going to be a fraction. And in the top part of our fraction, we have f prime of x minus g of x. Those are those inside values here. So f prime of x, that's just the number 7. And then we are going to multiply that by g of x, which is 12x plus 5. And then in the formula, there is a subtraction symbol. And then up in the top, we have f of x, which is that 7x minus 10. And we have, after that, g prime of x, which is the number 12. And then all of that is over g of x squared. G of x, that is that 12x plus 5. And then that, you can, they put brackets here. You can use brackets or parentheses. We tend to use parentheses more. So that is all over a 12x plus 5 squared. So again, as you go through and you take a look at this, here is our formula. We're doing the insides multiplied together minus the outsides multiplied together, and then all of that over the original denominator squared. So here's where we're at. Just like we did on the product rule, I am going to allow you just to stop here. Once you have that written out like that, you're done. You don't have to do any more. The answers in the back of the book, though, they're going to expect you to get rid of the parentheses up here in the top and combine some like terms. You might be tempted to cross out a 12x plus 5 on the top. In order for you to do that, we can't have any addition or subtraction outside of parentheses. So if you look at the top or the bottom, if you look at the top and the bottom, and you look outside the parentheses, there is subtraction right here. If we didn't have that subtraction, then we could cancel those out. But because we have some subtraction outside of parentheses, we can't. So let me show you how to get to the final answer in the back of the book. We want to get rid of the parentheses here in the top. To start with, to get rid of these green ones, I'm going to distribute the 7 in. 7 times 12 is 84, so we'd have an 84x. And 7 times 5 is 35. And then here, I'm going to want to not only distribute the 12 in, but also the subtraction. So this subtraction needs to get distributed to both of those terms, but so does the 12. So I'm going to multiply that 12 in also. So 12 times 7x, that's 84x, but then using the subtraction there and distributing that in, that ends up being a minus 84x. And then I'm going to do the 12 times the negative 10, that's negative 120, but then distributing the negative in also would be a plus 120. And then down in the bottom, we're just going to always leave this in parentheses squared. At the end, we would want to see if there are any like terms in the top that we could combine together, and there are, and actually 84 and 84x, those both cancel out. So that gives us 0 x's. We have 35 plus 120 on the top, so that's 155 on the top, and that would be over a 12x plus 5 squared. So again, the book would normally have us multiply this out, get rid of the parentheses using some multiplication, distributive property, or FOIL, or whatever it would happen to be on whatever problem you're working on, and then combine your like terms, and then we'd want to see if anything cancels here. So nothing canceled. This is our final answer. This is what would be in the back of the book for this problem, but I am saying we can stop just at this step here. So once you substitute in for your different values in the formula, then you can stop your work here. That's all I'm going to have you do on any test or any quiz that I have you work on. There's nothing wrong with going further on any of those. I'm just saying it's okay for us to stop here we can finish our workup using some pretty simple math that I'm confident you know how to do. And just like I talked about on the product rule, I'm trying to assess, I'm trying to see if you know how to use the quotient rule. So if you can get to this point, that shows me that. This isn't about getting rid of parentheses and reducing fractions. It's not what 12.4 day 3 is. It's about using this rule. So we don't need to do those last two steps. You can just stop here.